Laser boron fusion reactor with basic new properties. Experiments for laser-driven DT fusion were based on spherical irradiation of laser beams. The laser amplifiers of the NIF experiment cover most of the size of 3 football fields for the experiment where the beams are collected by a 10-meter diameter sphere to be focused into the center. The techniques of correct guiding, focusing, and temporal scheduling of 196 laser beams were developed for the laser boron fusion. The reactor is of spherical shape here too, but with the basic simplification that the ignition of the reaction is produced only by one laser beam. The wall of the reactor chamber of at least 1 meter radius for sustaining the generated helium nuclei. Alpha particle of 2.9 mega electron volt energy of 300 kilowatt-hour energy per shot has to be of steel or a similar material of at least millimeter thickness. The shock produced by the fusion reaction corresponds to that of a chemical explosive of about 50 grams. This comparably low shock compared with chemical reaction is due to the fact that this depends on the energy of the generated particles. This is given by the square root of the ratio between nuclear and chemical energy, reducing the nuclear explosion shock by a factor of few thousands against the chemical explosion. Apart from a softening to the shock front of the alphas, the basic difference to the reaction unit in the center of the sphere is that this is not for spherical irradiation but for a cylindrical geometry of the fusion full figure 3, about which details are to be discussed in the following section. If the unit is at the same potential as the sphere, the energy of the alphas is absorbed in the whole sphere and has then to be converted thermally for use in electric generators. Another advantage is that nuclear energy of the mono-energetic alphas can be changed directly into electricity with a minimum of thermal loss into cooling system of the unit is charged on a negative potential of less than but close to 1.4 volt. The alphas are then shot down when flying against the positive wall potential, and the electrostatic gained energy can then directly convert it into 3-alpha electric currents by techniques well developed by the HVDC high voltage direct current transmission line. This direct conversion of nuclear energy into electricity is indeed possible only if plasma discharge losses between the unit equipped with Faraday screening and the reactor wall can be sufficiently reduced. Otherwise, the energy conversion of the alpha is possible only by the heating of the wall material. What else is standard level for use in the HB11 reactor of Figure 2? Lasers for pulse up to picoseconds duration and more than 30 petawatt power are well expectable within few years. In 2017, lasers with 0.17 picoseconds, 10 petawatt power, and 1 shot per minute are in use, following Todd Dittmeyer and upgrading to the other specifications with 1 shot per second should be developed within the range of present-day technology, driven also for other most important applications than for laser boron fusion. The optical technology for guiding the 30 petawatt picoseconds of high contrast and modest fusing is on a much higher level developed for the case of NIF can be taken over. Well appreciate that the achieved level at NIF is on a breathtaking high level. The physics of the generation of the ultra-high magnetic fields in the coils is indeed an outstanding achievement following the work of Dido and Hohenberger using nanosecond laser pulse of usual level. Nevertheless, the standing of the field properties, the time dependence, and further improvement are of technology for laboratory projects on user level. The mechanical guiding of the reaction unit to the reactor center is indeed not an easy topic, but should be less difficult than the similar problems in the technology of microelectronic and may be taken over from there. The technology for repeating the positioning of the unit into the reactor center for one event per second were following solutions based on technologies envisaged by Issard Gaul.